Hello. I want to take this opportunity to acknowledge that we are all located on Mi'kma'ki, the ancestral and unceded land of the Mi'kmaq people. We are all treaty people. First off, Tuoi Seeing is a way of combining traditional knowledge of the land from those who lived here before us and the Western scientific approach. Here we have used a more Western approach as we attempt to observe the recovery process of Point Pleasant Park after the devastating Hurricane Juan in 2003. Sadly, we have no data from the years 2005 and 2007 due to other hurricanes, as well as the year 2020 due to the global COVID-19 pandemic. Our hypothesis our hypotheses follow the general idea of alternate being the forest follows the general positive relation over the years, whereas our null hypothesis generally follows the fact that there would be no relation between the time elapsed.
This experiment was conducted at Point Pleasant Park, which got hit by Hurricane Juan in 2003, resulting in an uprooting and deforestation of over 70% of the forest canopy. What was once a dense, mature forest turned into a bare ruin. 6 of the most impacted areas were selected for the field sites, which are 20 meters by 20 meters in length for data collecting, as seen in Figure 1. The data was collected for 1 hour every year since 2004, except for a few years due to hurricane activity or the pandemic. The same procedure was repeated by the Dalhousie students every year. Using the industrial standard for tree measurement, DBH, diameters of the trees were collected at 4.5 feet off the ground, and only living trees with the diameters over 2.5 centimeters were included. The trees were also identified to the lowest known taxon using a field guide or iNaturalist application. The ground flora data was collected by using a haphazardous placed wooden quadrant that was 1 meter squared. This was done by first having one person throw a brightly colored object over their shoulder, and wherever it landed was the center of their first quadrant. All the species within this frame was identified and was given a consensus estimate of percent coverage. Then this procedure was repeated starting from the first quadrant center. Each site per year collected a total of 12 quadrants worth of percent coverage information. We used linear regression analysis to examine the relationship of our independent variable, time, in years, and our dependent variables, total density, density of our dominant species, and richness, respectively. If these variables have a strong relationship, then the linear equation can be useful for predicting the future of Point Pleasant Park. However, if there is not a strong relationship, then we know that there are other elements impacting these variables.
This graph illustrates how total density, aka the number of individuals per 400 meters squared, in Point Pleasant Park has changed over time since Hurricane Juan. This was examined through a linear regression analysis of the relationship between year on the x-axis and total density on the y-axis. As presented, the regression indicates that the total density has increased from 2004 to 2025, demonstrating a positive relationship. The p-value for this test is equal to 3.9 times 10 to the power of negative 13, so we reject our null hypothesis at the p is less than 0.05 significance level. In 2003, Hurricane Juan caused extensive damage to the forest strands within Point Pleasant Park, destroying over 70% of the tree canopy. This level of disturbance created extensive gaps within the canopy, increasing sunlight availability and exposed mineral soil. These factors help facilitate rapid forest regeneration and early successional establishment, and since then, the forest has undergone a significant ecological transformation driven by secondary succession. We know that it's secondary succession because the soil was not destroyed as a result of the storm. Over time, as the forest has continued to recover, there has been a significant increase in total density observed. This increase represents the early stage regeneration, where many young trees established in the high light and high nutrient conditions. These results do not support our null hypothesis, and therefore we reject it. As the forest in Point Pleasant Park moves towards its climax community, density will continue to increase, but not indefinitely. In Acadian forests such as Point Pleasant Park, early pulses of regeneration typically lead to intense competition for resources among species such as light, water, and nutrients. When the density of the forest increases, so does the competition for these limiting resources, which eventually leads to a decline in density. This produces a more open, late successional canopy. The natural late successional vegetation types of Point Pleasant Park are dominated by species such as red spruce and white pine. As the forest continues to move towards its climax, these species will continue to grow and require lots of the limiting resources. These dominant species will compete for the same resources as the early successional species, resulting in a shift where the high densities in the forest, seen in the earlier years post-hurricane, will eventually lead to a more open and mature forest dominated by late successional species.
We used linear regression analysis to examine the relationship between the densities of these two dominant species and time. The number of red spruce and red maple individuals at each site increased over the study period, as you can see in Figure 3 and Figure 4. Although the density of both species rose over time, red maple increased at a higher rate than red spruce. The relationship between the species density and time were weak, with the time accounting for approximately 13% and 14% of the variance in the red spruce and red maple densities, respectively. These findings suggest that time alone is not a strong predictor for the species density and that other environmental factors likely influence the population dynamics of these dominant species. In 1984, one of the dominant regenerative species in Point Pleasant forests was red spruce. Red spruce is a shade-tolerant, long-lived species, with individuals typically living for 250 to 450 years. In contrast, red maple is shade-intolerant and relatively short-lived. The slow growth rate of red spruce compared to the fast growth rate of red maple helps explain how red maple has gained dominance in recent decades. The disturbance caused by Hurricane Juan increased light availability in the understory, creating favorable conditions for red maple, which thrives in high light environments and grows rapidly. Burley and al. Reported that red maple was the most abundant canopy sapling in 2005. However, these young trees did not have a diameter greater than 2.5 centimeters, excluding them from the sampling data within that year, until 2009, where they were included, and you can see a sharp increase in the density of red maple. This overtakes the red spruce's long-lived dominant position. As the forest matures and progresses towards climax community, red spruce is expected to regain dominance. Because red spruce is shade tolerant, it can persist and grow under a closed canopy where red maple, being shade intolerant, will likely decline as the canopy thickens and light availability decreases. Assuming no further major disturbances occur, red spruce may once again become the dominant species in Point Pleasant Park forest ecosystem.
Here we can see the graph depicting a positive relationship between the time elapsed since Hurricane Juan on the x-axis and species richness, aka the number of species on average, with an r-squared value of approximately 0.577. This indicates that we do not reject our alternate hypothesis of there being a positive relationship between the species richness and time elapsed, as you can see here. So, there was an overall increase in species richness at an average rate of approximately one new species per every other year. You might be wondering why there is an increase at all. Well, the devastation of the park left a massive gap in the ecosystem, thus leaving room for many new or returning species to take over. This led to an overall increase in species richness as compared to post-Juan measurements, because the niches that were previously occupied may be filled again. Essentially, the whole colonization phase that begun before the forest was founded is beginning again, and everyone is scrambling for the best niches. Following this, what would be happening as the species reaches a climax with the forest? Well, species richness would probably plateau in a kind of logistical curve, and hover around that quote-unquote ecosystem carrying capacity, hopefully perpetually. But this is because as more and more niches are filled, there will be less and less niches for new species to be able to fill without competition, thus creating a logistical curve, thus limiting the richness.
Based on statistically significant increases in total density, total species richness, and dominant species, the Acadian forest in Point Pleasant Park is most likely in an early to mid-successional stage. Immediately following Hurricane Juan, regeneration was dominated by early successional pioneer species such as red maple and paper birch. And since then, forest strands have been transitioning away from an open, early post-disturbance state towards a denser young forest. Pre-hurricane surveys showed the climax condition in Point Pleasant Park is dominated by red spruce, white pine, and hemlock on generally shallow, nutrient-poor to medium soils. The current regeneration in the park is still dense and strongly shaped by early and mid-successional species, which tells us that the forest is best described as being in early to mid-succession, and is still moving towards its climax community. Since Point Pleasant Park is an urban park, succession occurs under human-influenced conditions rather than fully natural conditions. Long-term management of the park can alter vegetation structure and increase the presence of non-native species, which can help explain the variation around our coefficient of determination, R-squared. The remaining 55% of variation in our model may be explained by parts of the park that have experienced higher levels of management. Also, the presence of man-made recreational trails throughout the park promotes more human activity, which increases disturbance and compacts soils. This reduces seedling establishment, making it difficult for new vegetation to grow. These urban factors can help explain why the forest maybe has not yet reached its climax community. Lastly, integrating Indigenous knowledge through a two-eyed seeing approach could strengthen the recovery of Point Pleasant Park by emphasizing respect for natural regeneration processes. Mi'kmaq perspectives highlight the importance of protecting relationships between species and allowing the forest to recover at its own pace. We can assist the recovery of the park by minimizing unnecessary disturbance and allowing nature to recover on its own timeline.
We would like to thank Allison Schmidt and Joanne Zigoris for writing and editing the experimental design and procedure. We would also like to thank all of the students that have collected this data for over 20 years through the course of Introductory to Ecology at Dalhousie University.
Our references included Burley et al. 2008, Yotkem Jr. et al. 1985, Steenberg 2010, and Turchin 2016. Thank you for listening.